So in this problem, we have a function here. This quadratic function, s of t, tells us the position of a particle that is moving back and forth along a coordinate axis in terms of t, which is our time variable. So imagine it like this. We have some coordinate axis that we'll call t, and the going to the right is the positive direction, going to the left is the negative direction. And then we have this particle that is just kind of going back and forth. It goes this way, and then it might go back this way. It goes back this way. But the movement of the particle is given by this s of t function. So the first thing we want to do is find the velocity, find v of t. Well, v of t is just the derivative of the position function. So it's just the derivative of s of t. So taking the derivative, well, here the first part of it is t squared. So applying the power rule, we multiply by 2 and then decrease the power by 1. So it's just 2t. Then we differentiate this part. The derivative of negative t will just be negative 1. And the derivative of negative 2 is just 0 because that's a constant. So that function v of t is 2t minus 1. Second part, when is the particle at rest? Well, at rest means that the velocity is equal to 0. So what we want to do is solve for t, the equation v of t, which is 2t minus 1 equals 0. So we're just solving this for t. So subtract 1 from both sides, and then divide both sides by 2, and we get that the answer is 1/2. The particle is at rest at 1/2, when t is equal to 1/2. The next part of the problem, part C, asks us to figure out on what time intervals is the particle moving from left to right and right to left. So here's what you need to think about when you're doing this. If I have a particle moving along a coordinate axis like this, so suppose the particle is right here, and it starts moving to the right. Before it can start moving to the left, it has to first come to a stop, and then it starts moving to the left. And then before it can start moving to the right again, it has to come to a stop. So the way we figure out the time intervals when it's moving from left to right is, first of all, determining when the particle stops. Well, that's what we already did. We did that in part B. So we know it stops only at t equals 1/2. It's the only time the particle stops. Okay? So that means we have to figure out what's going on for t greater than 0 and t greater than 1/2 and t less than 1/2, and that tells us everything about the motion of the particle because it only stops one time, so it can only change direction one time. So we're going to pick some test values. We have the intervals from 0 to 1/2, and we have the interval from 1/2 to infinity. And here at t equals 1/2, this is when the particle stops. This is when the velocity is equal to 0. So we just have to pick some test values. For test values over here, I'll pick 1/4. And in the interval 1/2 to infinity, I'll just pick 1. And then we just look and see what the velocity is. What the velocity is to know whether it's moving to the left or the right. So v of 1/4 will be 2 times 1/4 minus 1. Well, that's equal to negative 1/2, which is less than 0, which means the particle is moving to the left. And when the time is 1, v of 1 is equal to 2 times 1 minus 1. That's equal to 1, which is greater than 0, which means the particle will be moving to the right. So to sum all of that up, when t is in 0 to 1/2, the velocity is negative, so it's moving to the left. And then similarly, when t is in 1/2 to infinity, the velocity is positive, so it's moving to the right. And the last part, and I just noticed that this is a B, but of course that should be a D, wants us to use this above information to sketch the path of the particle along a coordinate axis. Okay, so to do that, the first thing we need to know is, where does the particle start? So that will be at s of 0, tells us where the particle starts. That's going to be at 0 squared minus 0 minus 2. So that's at -2. And we also want to know where does the particle come to rest. So that'll be at s of 1/2. That's going to be 1/4 minus 1/2 minus 2. So a little bit of arithmetic here tells us that is going to be at the point -9/4. And to simplify the sketch, we'll go ahead and write that as a decimal, -2.25. So let me draw something to be my coordinate axis over here. So here's 0, here's 1, 2, and 3. Right. I just noticed that I made a mistake. This is -2, of course, not a +2. That is -2. All right. So the particle, which I'll use red for that. The particle starts out at -2. So it's right here when t is equal to 0. And it's moving initially to the left. So the particle starts out moving in this direction. It only goes out to about -2.25, and then it stops and it turns around. So this happens when t is equal to 1/2, and then it doesn't change anymore. It just keeps going in this direction forever. So to do this type of problem, a lot of things are involved. You want to know how to take the derivative, know what it means to say that the particle comes to rest. That's when the velocity is 0. Know how to use the velocity to determine when it's moving to the left and to the right, and then put all that information together to sketch the path of the particle.